Today, we're diving deep into a mystery that's happening right in our own backyard, cosmically speaking, of course. We're talking about the sun. Some absolutely fascinating new evidence about its magnetic engine has just come to light, and it might just flip the script on what we thought we knew about our star.
You see, here's the thing you might not know. The sun is not silent. Not at all. It's constantly humming, vibrating with millions of sound waves that ripple right through its core. And hidden inside that cosmic song is the key to a powerful, invisible force that has a huge impact on us here on Earth.
So, the central question, the big mystery, is this. What, and maybe more importantly, where, is the engine that drives the sun's insane magnetic field? Scientists call this thing the solar dynamo, and for decades, its exact location has been a really hot debate.
Now, we see the effects of this engine all the time. It's what creates sunspots, those giant dark patches you see on the solar surface. It's what powers solar flares, these massive, violent eruptions of energy. And it's responsible for that famous 11-year solar cycle, the regular ebb and flow of the sun's activity. But the actual source of all this has been completely hidden from view.
So let's just be clear on what this solar dynamo is. In the simplest terms, it's the process where all that churning, flowing, superheated gas, what scientists call plasma, generates the sun's colossal magnetic field. It has to keep moving to sustain it, otherwise the whole field would just fizzle out. To solve this mystery, scientists have basically put together a lineup of three main suspects, three possible locations where this dynamo could be hiding. Think of it like a cosmic whodunit. So, let's meet the suspects.
First up, we've got a shallow location, the near-surface shear layer. This is a super turbulent zone right below the surface we see, where different layers of solar material are sliding past each other at insane speeds. This creates a ton of friction or shear, and for a while, some theories pointed to this as the main engine room.
Suspect number 2 is a much larger area, the entire convection zone. We're talking about the huge, boiling outer 30% of the sun. The idea here is that the dynamo isn't in one specific place, but it's kind of spread out through this whole massive, churning region.
And our third and deepest suspect is a place called the tachocline. This is a really thin, mysterious boundary layer about 200,000 kilometers down. It's a place of incredible friction, that shear again, where the chaotic outer part of the sun grinds against the deep interior, which spins more like a solid object. This intense boundary has been a prime candidate for the dynamo for a long time.
Okay, so we've got our suspects. But how in the world do you investigate something buried hundreds of thousands of kilometers inside a star? Well, the method scientists came up with is nothing short of genius.
I mean, that's the ultimate problem, right? You can't send a probe, you definitely can't drill into it, so how do you possibly peek inside a star?
The answer is a field called helioseismology, and you can pretty much think of it as a giant cosmic ultrasound. Seriously, scientists study those millions of sound waves we mentioned, the sun's hum, as they ripple and bounce around through its interior. You see, the speed and the path of these waves actually change depending on the temperature, the density, and the flow of whatever they're passing through. So by meticulously tracking them, scientists can build a ridiculously detailed map of the sun's hidden interior, revealing all its invisible currents and structures.
And using this incredible technique, scientists have just found a critical clue, a hidden fingerprint, if you will, deep inside the sun, right in the stomping grounds of one of our main suspects.
Okay, first, let's talk about a pattern we can actually see. For more than 100 years, astronomers have been plotting where sunspots show up. Over each 11-year cycle, they start appearing at the mid-latitudes and then pop up closer and closer to the equator. When you graph this over time, it looks just like a butterfly's wings.
So this leads to a really tantalizing question. If the dynamo engine is really deep inside the sun, could this visible butterfly pattern on the surface have a twin? A matching pattern hidden way down below?
And this is the breakthrough. This is the smoking gun. Using helioseismology, researchers analyzed flow patterns deep down near the tachocline, and they found it. A nearly identical butterfly pattern, but this time, it wasn't a pattern of magnetic spots, it was a pattern in how the sun's speed of rotation changes. And this deep flow pattern perfectly mirrors the magnetic pattern we see on the surface.
And hey, don't just take my word for it. Here's a quote straight from the research paper. The scientists put it plainly.
The rotation pattern deep down shows the exact same butterfly behavior. This is not a coincidence, people. It's a profound, direct link. It proves that what we see on the surface is directly tied to a hidden engine deep in the interior.
So, what does this all mean for our cosmic detective story? Well, this powerful new piece of evidence lets us draw a pretty darn strong conclusion about where the sun's engine is. Here's the bottom line. Finding this twin butterfly pattern so deep inside the sun, right there in the tachocline, is incredibly powerful evidence that the solar dynamo has a deep-seated origin. This engine isn't just some shallow thing happening near the surface.
This discovery really shifts the whole debate. The deep dynamo theory, the one that places the engine in or near the tachocline, is now strongly supported by this direct observational evidence. And on the other hand, that shallow dynamo theory, it's now seriously challenged, because this new data shows that these important flow patterns aren't just near the surface, they extend all the way down.
So why does any of this matter? Well, first, figuring out the engine is a huge leap towards being able to predict the sun's activity, things like solar flares that can mess with our satellites and power grids. It also forces scientists to rethink some pretty basic theories about how stars in general actually work. And finally, by understanding our sun's dynamo, we get major clues about the magnetic engines of countless other stars all across the universe. It really just leaves you with this final incredible thought. If we were able to pinpoint the sun's hidden engine just by listening to it hum, what other amazing secrets are out there just waiting for us to uncover if we just keep listening to the songs of the stars?